It is a clear morning in a small town in Washington state, and the sirens are screaming, not a test tone, the real thing, a wail rolling across rooftops and playgrounds. And here is the strange part. Nothing is happening. The sky is blue. The birds are singing. And on the horizon, enormous, white, serene, stands one of the most beautiful mountains in America. At the elementary school, the children do not panic. They line up, just like they have practiced, and they begin to walk, quickly, toward higher ground, because in this town, every child knows two things that most Americans do not. The first is that the beautiful mountain on the horizon is one of the most dangerous volcanoes in the country, and the second is stranger. And it is the reason for this entire video. That mountain does not need to erupt to destroy their town. It only needs to fall, and the ground their school is built on is the proof that it has fallen before. This is Mount Rainier, and by the end of this video, you will understand why scientists watch it around the clock, why entire towns below it hold evacuation drills for a disaster with no eruption in it, and why the official position of the people who study this mountain is not if it happens again, but when. Start with the mountain itself, because the postcard hides everything that matters. Rainier is enormous, over 14,400 feet, towering above the suburbs of Seattle and Tacoma, visible from 100 miles away on a clear day. Millions of people see it daily and feel lucky to live near it, but strip away the beauty and read it like a geologist, and the mountain becomes a list of alarming facts. It is an active volcano, part of the same Cascade chain as Mount St. Helens. It sits on the short list of 16 volcanoes worldwide that scientists designated for special study, because they combine active systems with large nearby populations, and it carries something no other volcano in the lower 48 has: ice. Rainier holds more glacial ice than every other Cascade volcano combined, roughly a cubic mile of it, frozen onto the slopes of an active volcanic system. Remember the ice. The ice is the loaded weapon. Now the part almost nobody outside the scientific world knows. Mount Rainier is rotting, not metaphorically, chemically. Deep inside the mountain, volcanic gases and hot acidic fluids have been circulating through the rock for tens of thousands of years. An acid does to volcanic rock what rust does to steel. It transforms hard, strong lava rock into soft, crumbly, clay-rich material in places with the strength of wet garden soil. Scientists have mapped these weakened zones, particularly high on the western face of the mountain. Enormous volumes of altered rock, saturated with water, sitting at steep angles, thousands of feet above the valleys. Engineers would never allow a dam to stand in that condition. Nature does not ask engineers. So, picture Rainier honestly. Not a solid mountain, but a colossal, steep, partially rotten structure, loaded with a cubic mile of ice, standing directly above valleys full of towns. Which brings us to the word this entire video turns on: Lahar. It is an Indonesian word, because Indonesia has suffered them for centuries, and it describes what happens when volcanic material and water move together. A lahar is not lava. It is not an avalanche of snow. It is a flood of liquid concrete, rock, mud, sand, boulders, shattered ice, trees, and eventually houses and cars and bridges, all churning together into a gray slurry that flows like a river but hits like a landslide. In the steep upper valleys, a big lahar can move at highway speeds, far faster than anything on foot. Survivors of lahars around the world describe the same two details: the sound, a roar like a freight train that grows until it fills everything, and the way the flow seems to breathe, surging in pulses, each wave higher than the last, carrying boulders the size of cars that bob on the surface like corks. It does not flow around obstacles, it absorbs them. A lahar entering a town does not knock buildings down the way wind does. It fills them, floor by floor, from the inside, while dragging the structure off its foundations. And, when it finally stops, it sets, like the concrete it resembles, entombing everything it carried. Rescue crews who work lahar zones will tell you that once the flow stops, digging is nearly hopeless. The material hardens around whatever it holds. Everything about survival is decided before the Lahar arrives, by who moved early, and who waited. If you want to know what a Lahar does to a town, history has already run the experiment, and the result is one of the darkest nights of the 20th century. November the 13th, 1985, Colombia. A volcano called Nevado del Ruiz, capped with ice, just like Rainier, produced an eruption so small that ash barely dusted the towns below. But the eruption melted part of the summit ice, and the meltwater mixed with volcanic debris and poured down the river valleys as lahars. 2 hours downstream sat a town called Armero, a farming community of almost 30,000 people. It was night, it was raining. Warnings had been discussed for hours, but they were confused, contradicted, delayed. Most people were told to stay calm, many were asleep. Just before midnight, the Lahar arrived, a wall of mud and debris that swept through the town in minutes. By morning, Armero effectively no longer existed. More than 20,000 people died there, in a disaster caused by a minor eruption, on a volcano everyone knew was active, in a town that had hours of warning and did not move. In the days that followed, the world watched the rescue effort on television and learned the cruelest property of Lahar mud, that it holds what it takes, and that even rescuers standing beside survivors often could not free them from it. The images from Armero change volcanology forever. Scientists call it the great preventable tragedy, and it haunts the field to this day, because the science had done its job. The hazard maps existed, the warnings were technically issued, and the town still died. In the gap between knowing and moving, every Lahar plan on Earth, including the ones below Rainier, was written in the shadow of that gap. The instruments, the sirens, the drills, all of it exists to make sure that when the science speaks, the moving starts in minutes, not hours. Now, hold Armero in your mind, and look again at the valleys below Rainier, because the geological record there tells us this mountain has already done it, on a scale that dwarfs Colombia, and more than once. Around 5,600 years ago, the summit of Mount Rainier collapsed, not an eruption in the Hollywood sense, a structural failure of the volcano itself, likely triggered by volcanic activity destabilizing that weak, rotten rock we talked about. The entire top of the mountain, more than 1,000 vertical feet of it, let go and became a lahar beyond modern imagination. Scientists call it the Osceola Mudflow, and the numbers around it barely sound real. It carried enough material to bury the entire island of Manhattan many feet deep. It roared down the White River Valley, over 60 miles, burying the land under mud and debris dozens of feet deep, and it did not stop until it reached the waters of Puget Sound, pushing the shoreline itself outward, adding new land to the map of Washington. The mountain you see today, with its slightly flattened, broad summit, is the stump of the taller mountain that existed before that morning. It buried an area of well over 100 square miles. Today, the towns of Enumclaw, Buckley, and parts of Auburn and Kent, suburbs of the Seattle metropolitan area, tens of thousands of homes, sit directly on top of the Osceola deposit, the flat, fertile, buildable land that made those towns possible is the corpse of the mountain's former summit. And if 5,000 years feels like ancient history, the mountain has a more recent message. Around 500 years ago, a section of Rainier's weakened western face collapsed and sent a lahar, known as the Electron Mudflow, down the Puyallup River Valley. It buried the valley floor under mud up to 30 feet deep, flattening the old growth forest that stood there. And here is the sentence that should stop you. Scientists have found no clear evidence of an eruption at that time. As far as the record shows, the mountain simply let go. No warning eruption, no dramatic buildup. A piece of the rotten structure reached its failure point, and a valley died. The town of Orting, the town from our opening scene, with its schools and its sirens, is built directly on top of the Electron deposit. When those children practice walking to high ground, they are walking on the last lahar, rehearsing for the next one. That is the full picture. A rotting, ice-loaded volcano, valleys that have been buried repeatedly, And on those same valley floors today, not empty forest, but a continuous corridor of towns and cities. Orting, Puyallup, Sumner, down toward the port of Tacoma. By the most cited estimates, tens of thousands of people. Some estimates say well over 100,000 live and work directly on top of old Rainier Lahar deposits, with schools, hospitals, and highways woven through the same corridor. And the valleys keep growing. The Puget Sound region is one of the faster growing parts of the country, and the flat valley floors are exactly where the affordable land is, which means every decade, the number of people living on the old mud quietly rises. The mud has a return address, and we built on it, and we are still building. So, what happens next time? Walk it through, because the emergency planners have, in detail. It could begin with an eruption. Rainier is capable of them, and even a modest one melting part of that cubic mile of ice would send Lahars down multiple valleys at once. But remember the Electron. It could also begin with nothing, an earthquake, even a moderate one, shaking that weakened western face past its limit. And remember from our Cascadia episode what this region's earthquakes can do. 6 minutes of shaking is a long time to hold up a broken mountain, a period of heavy rain saturating the altered rock, or simply gravity, finishing a calculation it has been working on for centuries. On the mountain, it would look like a piece of the upper slopes turning to motion, a dark mass accelerating downhill, shedding ice, gathering water, transforming within minutes from landslide into Lahar. From that moment, the clock runs. For the town of Orting, the modeled arrival time of a major Puyallup Valley Lahar is on the order of 45 minutes to an hour. That is the entire budget, for everyone, to get to high ground, not to pack, not to drive into gridlock, to move, on foot if necessary, up the valley walls. 45 minutes is survivable, if, and only if, people know instantly and move immediately, which is why what exists in those valleys today is genuinely remarkable, and almost no one outside Washington knows about it. Because Rainier is one of the only volcanoes on Earth wrapped in a dedicated Lahar warning system. On the upper flanks and in the valleys, instruments listen constantly for the specific ground vibration of a moving Lahar, a signal utterly different from an earthquake. The system is designed to detect a flow within moments of it forming, automatically, day or night, and trigger the sirens downstream. Those sirens are tested on schedule, month after month. So every resident knows the sound, the schools drill. The evacuation routes are marked with signs on ordinary streets, arrows pointing uphill, in the middle of normal American suburbs. One school district even planned its buildings and routes around the walking time of its youngest children, and the town of Orting spent years campaigning for a dedicated pedestrian evacuation bridge across the river. A bridge whose entire purpose is to shave minutes off the walk between the schools and the safe high ground on the far side. A bridge designed around the speed of a walking child and the speed of moving mud. That is what it looks like when a community takes the geological record literally. They are not paranoid. They are prepared for the event their own ground proves is real, and understand what is at stake beyond the towns themselves. The Puyallup Valley runs downhill into the tide flats of Tacoma, one of the busiest port complexes on the West Coast, a hub for the shipping that feeds the entire region's economy. The largest modeled Lahars do not stop at the small towns. They follow the valleys all the way to the sea, just as the Osceola did 5,000 years ago, which means warehouses, rail yards, highways, and port terminals are all built on ground the mountain has reached before. A major Rainier Lahar would not just be a local tragedy, it would sever a piece of the American supply chain. The same lesson we keep finding on this channel. The threats are always aimed at the arteries, and the mountain is watched from every angle. Seismometers listen to its internal creaks. GPS stations measure any swelling of its slopes. Cameras and satellites track its glaciers. And the glaciers themselves keep offering small reminders of what the mountain is capable of. Even without any volcanic activity, Rainier's valleys experience smaller debris flows in ordinary years, sudden floods bursting from the glaciers after hot spells or heavy rain, tearing out sections of Park Road, rearranging riverbeds, occasionally forcing closures. Park visitors sometimes hear them before they see them. That same freight train roar, in miniature. These small events hurt no one most years, but scientists value them enormously because they are the mountain rehearsing, showing exactly which channels the big one would take. The rivers draining Rainier are literally running through the debris of previous collapses, and every few years they move a little more of it downstream. The scientists at the Volcano Observatory responsible for the Cascades treat Rainier as a permanent patient, because among American volcanoes, it is consistently ranked in the top tier of threat, not because it erupts often. It does not, but because of the arithmetic this video has shown you. Weak rock, plus massive ice, plus deep valleys, plus large populations, equals the highest stakes in the Cascade chain. Now, the honest section. Because this channel does not do fake countdowns. What are the actual odds? Rainier erupts far less frequently than a volcano like St. Helens. Its last significant eruptive period was roughly 1,000 years ago, and there is no sign of an imminent eruption today. The seismic activity is normal, the gas output is normal. Nobody credible is telling the people of Orting that the Lahar is coming this year, and neither am I. But the annual probability of a major Lahar is not zero. It never is, and unlike an eruption, a collapse-driven Lahar may offer little or no long-term warning. That is why the official language around Rainier's Lahars, from the people who study it professionally, leans on the phrase when, not if. The Osceola happened, the Electron happened, probably without an eruption. The rock is still rotten, the ice is still there, the towns are still in the valleys. Nothing in that equation has been solved, it has only been monitored. So, 3 futures, the honest way to hold Rainier. Future 1, the overwhelmingly likely one in any year you pick. The mountain stands there, beautiful and silent. The sirens get tested, the children drill, tourists climb it, Seattle takes its photographs. Most years are this year, and it is entirely possible the mountain stays quiet for generations. Future 2, the middle path. Rainier stirs, a swarm of earthquakes, steam explosions, maybe a modest eruption like the Cascades have produced many times. Ash disrupts flights. Small lahars run partway down the valleys. The warning systems work. The evacuations happen, and America suddenly remembers, vividly, that a fully active volcano stands above one of its major metropolitan areas. Future 3, the big collapse, with or without an eruption. A large section of the weakened flank fails, and a major lahar enters the populated valleys. In this future, everything reduces to one question, the Armero question. Do the people move in the first 10 minutes, or do they hesitate? The instruments will do their job in seconds. The sirens will do their job in seconds. The entire outcome, tens of thousands of lives, rests on whether the human beings believe the sound and walk uphill. That is why the drills in Orting matter more than any instrument on the mountain. Armero had warning and lost 20,000 people. Orting intends to be the opposite story. Here is my honest opinion. After everything the research shows, we spend our fear on the wrong volcanoes. The internet obsesses over Yellowstone, a system with almost no chance of erupting in our lifetime, while barely anyone outside Washington state can explain what a lahar is. Even though the Lahar hazard at Rainier is vastly more likely, vastly better documented, and aimed at real neighborhoods you can drive through today. Rainier is not dangerous because it is angry. It is dangerous because it is heavy, broken inside, covered in ice, and patient. And the towns below it have done something quietly heroic. They have chosen to live with the truth instead of ignoring it. Sirens, drills, signs pointing uphill. That is not fear, that is respect. The rest of the country could learn from those valleys, because every place in America has its own version of Rainier. A documented threat everyone has decided not to think about. So now I want to hear from you. Did you know a mountain could bury towns without erupting? And have you ever seen Rainier in person? Maybe even lived in one of those valleys? Orting, Puyallup, Enumclaw, Tacoma, Seattle. Drop your city in the comments. I read everyone. And if you have heard those sirens tested, tell me what it feels like. If this video taught you something the news never did, hit the like button It genuinely helps this channel grow. And subscribe with notifications on, because next, we finally take on the famous one, San Andreas, the most talked about fault in America. And the truth is, almost everything you think you know about it is wrong. What it can do, what it cannot do, and the city that should actually be worried. That story is next. The ground beneath America is speaking. Make sure you are listening.